Okay, this video is going to introduce us to the last operation that we need to do with polynomials, and that is division. And we're going to begin with the simplest type of division, and that is when you have a polynomial and you have a greatest common factor of your terms, and you divide that out. So let's begin. So just to review, I want to show you that here is a monomial being multiplied by a binomial. And you know we've just been doing this where you distribute the multiplication across both of your other terms. So 5 times 1, there's a 1 there. 5 times 1 is 5. P times P is P squared. And then we do it for the other term too. 5 times 3 is 15. And P times 1, because you know there's a 1 there, is just P. So now you see that we've multiplied this, and we could just as easily undo it by dividing by what we just multiplied by. So once again, we're going to cross cancel the P's. They're going to cancel out. 15 divided by 5 is indeed 3. Okay, over here, 5 times 5, 5 and 5 are going to cancel each other out. That equals 1. Any number over itself is 1. And then by our laws of exponents, when we divide exponents of the same base, we can subtract them. So 2 minus 1 is 1. P. So now you can see how this works. We started off with a multiplication, we multiplied, we divided and undid the multiplication, which brought us right back to the place where we started. So, the key to success when you're dividing a greatest common factor out of a polynomial is to make sure that you are dividing the largest combination of constants and variables. And this is what I mean by that. So let's take a look at this. We have a negative 16k squared plus 12k. Okay? So we have a combination in both of these terms of variables and numbers. So let's start with the variables. So I have 1k here, and I have 2k's here. So the largest number of variables that I could divide out of these two terms is 1. You see, I can't divide by a number larger than what I've got here, which is 1. So I'm going to write a k. So now let's take care of the numbers. Let's look at these numbers. Well, both of these numbers have a lot. They have several factors. Each one of them do, right? I can divide both of these numbers by 2. I can divide both of these numbers by 4. Okay? But I want the largest number that both of these will evenly divide, that will divide both of these evenly. And that would have to be 4. So I'm going to write 4 here. So now I can do my division. I'm going to, k over k is just 1, and 12 divided by 4 is going to be 3. I'll keep my plus sign. So I'm dividing negative 16 by positive 4. So I've got 4k on the outside of my soon-to-be binomial. And so negative 16 divided by 4 is negative 4. And once again, when I divide exponents that have the same base, I am subtracting the exponents. So 2 minus 1 gives me 1. And voila, there I have it. I have factored the largest common factor out of these two terms, and so now I have 4k times negative 4k plus 3. And before we end this video, I would like to make one last point. Factoring equals dividing. We use those terms interchangeably when we're talking about polynomials. As you can see, just like you did in elementary school, when you divide a number like 12 by a number like 4, and you end up with another number, 3, you can multiply those two numbers back together to get the number that you started with. What do we call this in arithmetic? We call 4 a factor. We call 3 a factor. Same with polynomials. We started off with negative 16k squared plus 12k. We realized that we could divide both of these terms by 4k, and what do we get? We start off with a sum. We're adding these two terms together, and we are ending up with a multiplication problem, just like here. 4k is a factor. Negative 4k plus 3 is a factor. We can now multiply this back and end up with the polynomial that we started with. So that is our intro to dividing polynomials. In the next video, we'll talk about long division and the process of factoring.